Venus has always been the mysterious twin of Earth, the same size, the same gravity, and orbiting close enough to seem familiar. But what lies beneath its thick yellow clouds is something no one expected. For years, Venus was just a bright dot in the sky, a dazzling morning star. But now, thanks to new radar imaging, updated probe data, and advanced telescope scans, we finally know what this world truly looks like in 2025. The result is nothing like the beautiful orange planet in textbooks. It's something far more alien, violent, and alive. At first glance, Venus might look calm from space, wrapped in smooth clouds that reflect sunlight so strongly it outshines every other planet. But those clouds are deceiving. They're made of sulfuric acid, hiding a planet where the air pressure is 90 times stronger than Earth's, and the surface burns at over 465 degrees Celsius, hotter than Mercury, even though Venus is farther from the Sun. For decades, no visible light camera could penetrate that haze. But now, new technology has made it possible to see through the clouds, not with light, but with radar, near-infrared imaging, and reflected radio waves that expose the planet's real terrain. The most dramatic transformation in our view of Venus came from radar mapping. Instead of trying to photograph the surface directly, scientists use radio waves, signals that can cut through the thick atmosphere. Ground-based observatories on Earth, like the Green Bank Telescope, teamed up with powerful transmitters to bounce radar off the planet and collect echoes from its surface. The data, gathered over years, revealed massive plains of hardened lava, fractured mountain ranges, and vast volcanic fields stretching for hundreds of kilometers. These scans showed us Venus not as a smooth marble, but as a world of chaos, cracked, crushed, and reshaped by endless geological violence. Even more incredible is what happened when researchers compared radar images taken years apart. In some regions, like the volcanic area known as Planitia, surface features had changed. Shapes shifted. Some radar reflections grew brighter, others dimmer. At first, scientists thought it might be noise, an error in the data. But when the same pattern appeared in multiple scans, the conclusion became hard to ignore. Parts of Venus were moving. These subtle changes pointed to something extraordinary, signs that the planet might still be geologically active, with magma rising and falling beneath the crust. In other words, Venus might not be a dead world at all. It could still be alive in its own fiery way. That theory exploded in 2023, when new analysis of archived radar data found clear evidence of a volcanic vent on Venus that had changed shape in less than a year. The vent, located near the massive volcano Mont Mons, appeared to have collapsed and filled with fresh lava between scans. Then in 2024, even more areas showed possible signs of activity, small but unmistakable surface changes linked to volcanic processes. These discoveries prove that Venus is still erupting, still reshaping its own face beneath the clouds. It's not a fossil planet frozen in time, it's still breathing heat. This active geology also explains the bizarre chemistry of Venus's atmosphere. The planet's clouds are full of sulfur dioxide, a gas that doesn't last long unless something keeps replenishing it. Volcanic eruptions could be doing exactly that, injecting fresh gases upward through the dense air. Some researchers even speculate that small, continuous eruptions might explain the mysterious dark streaks and ultraviolet absorbers seen in the upper clouds. Venus, in this sense, isn't just glowing from the sun, it's glowing from within. But one of the most surprising images of Venus didn't come from a mission designed to study it at all. In 2020, NASA's Parker Solar Probe, built to study the sun, captured something no one thought possible. During one of its gravity-assist flybys of Venus, the probe's camera, meant for solar imaging, was pointed at the planet's night side. And against all expectations, it recorded faint, visible light coming from the surface. What the camera saw wasn't sunlight reflected off the clouds. It was the planet itself glowing, a ghostly thermal shine from the burning hot rocks below. You could make out real terrain features like ridges, plains, and highlands shimmering through the haze. For the first time ever, we weren't seeing a radar reflection or a simulation. We were seeing Venus's actual surface in visible light. The Parker image was so unexpected that it changed how scientists thought about observing Venus. It showed that, under the right conditions, Visible and near-infrared light can penetrate the atmosphere just enough to reveal what's below. That single image opened a new chapter in Venus research. Now, upcoming missions are being equipped with instruments tuned to those same wavelengths, hoping to repeat what Parker did, but with far greater clarity. Today, scientists can even track subtle movements on Venus from Earth without needing orbiters or landers. Advanced radar systems fire pulses of radio energy across millions of kilometers and pick up the faintest echoes, signals so weak they're nearly lost in noise. Yet from these whispers, we can build detailed maps of craters, volcanoes, and valleys. These radar images have become so precise that researchers can compare scans years apart and detect surface changes smaller than a few hundred meters. The ability to do this from our own planet is astonishing. It's like taking a CT scan of a world hidden behind a curtain. These methods also confirmed something else. Venus's surface is surprisingly young. When scientists counted impact craters, they found too few for a planet that old. That means something. Perhaps volcanic resurfacing wiped the slate clean not long ago, at least in geological time. The surface we see today might be only a few hundred million years old, meaning Venus could have melted itself down and started over. Imagine an entire planet erupting and resetting its crust. That's the kind of event Venus seems capable of. The next decade will bring the clearest answers yet. NASA's Veritas mission, planned for the early 2030s, will orbit Venus with high-resolution radar powerful enough to detect surface changes smaller than a single meter. The European Space Agency's Envision mission will peer deep into the crust, searching for signs of tectonic movement and underground heat. And NASA's Da Vinci Plus probe will do something no one has done in decades: descend through the atmosphere itself, directly sampling the chemical layers as it falls toward the surface. Together, these missions will rewrite what we know about Earth's closest planetary neighbor. If the current evidence holds true, we may soon witness something extraordinary: the first confirmed active volcanoes on Venus caught in real time. Imagine seeing glowing rivers of lava flow under that suffocating sky with temperatures high enough to melt metal. These new missions will also study the gases escaping into space, helping to determine how Venus lost its water and why its atmosphere became a runaway greenhouse trap. That knowledge isn't just about Venus, it's about us. Understanding what went wrong there could be a warning for Earth's own future. The most haunting realization is that Venus might have once been like Earth. Billions of years ago, it could have had oceans, clouds of water vapor, and maybe even a stable climate. But something changed. Volcanic eruptions, atmospheric feedback, or runaway heat, and the planet transformed into the hellish world we see now. The more we learn about Venus, the more it feels like looking into a mirror that shows what Earth could become if our climate ever spins out of control. If you're fascinated by the mysteries of space and the planets that orbit beside us, make sure to like this video, subscribe for more deep space explorations, and turn on notifications so you don't miss what's next. Because the story of Venus is only beginning, and the next time we look through those clouds, we might finally see the planet as it really is.